Hi everyone, my name is Mengyuan Liu, and my project name is League of Legends: Who to Win. Phase 1 is business understanding. My goal of this project is predicting which team in League of Legends will win the game by using the data retrieved from Kaggle. This dataset contains about 10,000 observations of 40 variables. Contains both categorical variables and numeric variables. And then is my preliminary plan. You can see there. And phase 2 is data understanding. First, I eliminated the variables that can be represented by other variables. Then I will detect the outliers in the dataset by using z-score. And then I finding clusters. Since there are too many outliers in the data, I checked whether there are clusters in the data by using DBSCAN algorithm, which is resistant to outliers in the data. And the right figure is the result. The result shows that the data only contains one cluster, which contains lots of outliers denoted by the black points. And then I check the multicollinearity. You can see there are some dark ones in this figure. This shows that there are collinearities between these independent variables. And phase 3 is data preparation. The first part is data imputation. Since it is nonsense that the number of words placed by each team has values larger than 70 in the first 10 minutes, I'm going to impute those values by using the KNN algorithm, KNN regression algorithm. And the second one is derived features. Considering that whether the blue team will win mainly depends on the difference between these two teams. Thus, I decided to derive some new variables based on the variables I have, like gold difference equal to gold earned by the blue team minus gold earned by the red team. Then I deleted outliers, since some algorithms that I'm going to use are sensitive to outliers. Thus, I decided to remove them. There are about 70 outliers in the data. And then I do the PCA. Since multicollinearity matters to the models, I'm going to use PCA to eliminate multicollinearities. You can see my data preparation part there. This is the data imputation process, and this is how I generate new derived features. And then I detect outliers and eliminate them. After that, I do the PCA. And I use the scale and center parameters in the PRCMP function to do the normalization. And this is the result of the PCA. Phase 4 is modeling. For building the model, since all my features are numeric ones and I'm going to do the classification prediction, thus I decide to use algorithms KNN, logistical regression, SVM, and ANN. After evaluating the 4 models and doing the improvement, I will build an ensemble model using the majority vote. And phase 5 is evaluation. I use K-fold cross-validation, AUC, and confusion matrix evaluate models, since they are methods to evaluate the classification results. Besides, since AIC and K-fold class validation usually do the same thing, I didn't use AIC in my cases. You can see the results of my models here. This is the validation of the K-fold cross-validation of the KN model. And you can see accuracy was used to select the optimal model using the largest value. The final value used for the model was K equal to 9. And accuracy will be 0.68. And this is the result of the KNN model. Its accuracy is 0.7 about, and this is the AUC. This is the logistic regression model, and you can see this is the result of K-fold cross-validation, and this is the AUC of this model, and this is the accuracy of this model. And this is the SVM algorithm. This is the AUC of this model. This is the result of cross-validation. This is the accuracy of this model. And I tuning the SVM model by changing kernel to the vanilla dot. And this is AUC. And this is the cross-validation result. This is the accuracy of this model. And then I use the Keras package to build the ANN model. This is the cross-validation accuracy, and this the accuracy of the training model, and this is the AUC of this model. The second part is my comparison of models, you can see there. Then I do the ensemble. Since the KNN model doesn't have higher accuracy, I'm not going to add it to the ensemble model. What's more, as the SVM model has higher AUC, I'm going to add its weight in the ensemble model. Although the ensemble model doesn't have higher accuracy, its sensitivity increases, which means it will have higher accuracy on predicting the winning of the blue team than any other models. The final part is the deployment. I create an interactive dashboard using Shiny, and I upload it to the GitHub. And you can see there are many ways to download and run it. You can just copy this code and go to our console and paste it. And then you can change the value here like this. Press the submit button and the result will show here. Okay, the last part is summary and key lessons. First, if there are too many outliers in the data may exist clusters. One needs to check the cluster first. And second, the performance of the model is not determined by the complexity of the model, but the characteristic of the data. Third, for constructing an model, it usually performs well by having one header layer and setting the number of neurons in that layer equal to the mean of the neurons in the input and output layers. The last one, keep in mind what's the data like. At first, I really confused about the low accuracy of my models, but after reconsidering the data, I realized that makes sense. Thus, I only used the first 10 minutes of the game, which durations are usually 30 minutes, to predict a result. Thank you all and have a nice summer.